Right, we're back here now. I've drawn the circuit a little bit differently and people look at it and get confused. So if we redraw this out in its simplest form, we get a circuit that looks like this. So redrawn out, we have 90, 120, 30 and 60, okay, and 320 volts. So what they've asked, I'm going to say on here, is we need to find the voltage drop of this, the pair of this, and the current of this. Right, so we're just going to break it down, have a look again. So let's go back to the start again, where we always start off with. We always have Ohm's law, so that's times and that's divide. P equals I squared times R, like I always say. P equals V squared over R, and P equals V times I. Remember, this one's for a series circuit, this one's for a parallel. And I've shown you in these examples here how they work, and this is for total power, if you need to. Alright, pence. Okay, so first thing, like I said, we always go for the resistance total. So I'm going to go for 60 plus 1 over 90 plus 1 over 120 plus my 30. The next one will be current total, V over R. But first thing we need to do is get the common value between these two here. So coming back to my calculator, we are now going to do 90 over x1. Remember this x1 key that I pointed out before? 1 over 90 plus, okay, 120 over, so now I've got 120 and 1 over 90. I'll equal it, push this again to re-invert it back, and I get, just change that a bit, 51. So I've now got 51.4 plus my 60 plus my 30. Okay, so I've got 51.4 here. That number cannot be greater than the lowest number in the parallel circuit. That's a thing you must take into account too. All right, so those added up together. So I've got another 90, so that plus 90, just to put it quickly, equals, so we get 141.4. Okay, so now I apply that to my voltage total current, 320 divided by 141.4. This looks like it's going to go in there 2 times, so we clear that. So 320 divided by 141.4 equals, all right, 2.26. Okay, right, so now when we look at this, we've got total current, total resistance and total voltage. I can use them to move anywhere in that circle. The first thing I always look at, if I've got something in parallel, all right, and they're asking me to do something in that parallel circuit. So here they're asking me to do the voltage drop of the 90 and the power of the 120. So for me, the first thing I always do is work out the voltage drop, and then we go to whatever we need next. So voltage drop, what do we got? Voltage drop, we need to times, if I cover this up, we have I times R. Okay, so I times R is equal to 2.26 amps times, now I can't use a 90 or 120 because they're in parallel and the current splits between. So the value that was between these two was 51.4, which we saw down here. That was a common denominator to act like one resistor. So I'm going to times that by 51.4, which is our common value resistor, and we get 2.26 times 51.4 equals 116.8 volts. Okay, so that is done for our voltage drop. The next one they're asking is for power. The power of the 120 resistor. The voltage drop was for the 90 ohm resistor. So power of one thing. Remember, power, it's in parallel. What do we do in parallel? V squared over R. So V squared over R equals. Now the voltage drop I got was 116 because that's the same across the two resistors. 116 up here, 0.8 was the voltage drop. So 116.8 squared divided by the resistance was 120, okay, and my answer will be in watts. All right, so 116.8 squared, all right, divided by 120 equals, we get 113.6 watts. What did you say? Watt. So that's what we're looking for. That is carried out for my P. Now I, and the funny thing about it, the current comes through here. It's 2.26. It gets to here, it splits, comes back to the same. So here it's 2.26. So if we're looking at the current in the I30, all right, I30, the current is equal to the current total, which is equal to 2.26 amps. So our answer for that is 2.26 amps, because it's in the series part of the circuit. It doesn't change. All right, so I've gone through that one. I'm going to do a couple more, but you can start seeing when we break things down. Step 1, resistor total. Step 2, current total. Then anything in voltage drop we work out, we must do that. 3. Then if we've got power in that or current in that, we do that as a 4th step. And the last one, sometimes you could do the current first, it doesn't matter, it's not going to make any difference, but you work your way through. So 1, 2, 3, 4, 5, done. Notice I've done all the formulas, 2 formulas and everything. Don't just punch it into the calculator and then go, oh, that's the answer. All right, it says in bold lettering on the LET, all calculations and values must be shown to obtain full marks. Okay, I'll leave that one and we'll go on to another one shortly.